It could be anything.
Oh, I see YouTube streaming is started. Yeah, I expect that all the heavy lifting on YouTube is done by FFmpeg, so we can legitimately say that it is C.
There we go. Google says or Wikipedia says YouTube is C, C++, Python, Java, and Go. I have no idea where Wikipedia has that information from, but that's what it says.
There is one rule: never trust Wikipedia.
Yes.
Hi, Yuri. Hi, Tom. Nice to see you. Shane, Geoff, Igor. Let more people join, and we will start maybe in 30 seconds. Christoph, you tell me when to start.
All right. I think Yuri just answered our question about what YouTube is built in Go and C++. I guess I was wrong. Yuri would know.
I hope. Some information may be outdated. Maybe it was rewritten in PHP. Who knows?
Like Facebook.
Facebook is using some kind of bastardized version of PHP.
I think they like binary compile it or something, right? Like cross compile it. So basically it's like PHP and then it's compiled to basically C++ or something like that. Who knows? It's probably not very pretty to write code for it. I don't know. Oh, well, we can get started. So welcome everybody. Welcome to our June release webinar. I think some of you we've met last week in person at the Amsterdam meetup. By the way, if you were not able to attend the Amsterdam meetup, we have a recording on the ClickHouse YouTube channel. So feel free to check it out and maybe jump around a bit. It's rather long recording, but I think there's some interesting pieces in there. As usual, Alexei will walk us through the new features in our release, and we'll also answer any questions. So feel free to post any questions in the chat. I see the chat is very lively today. Actually, it's great. So just feel free to post your questions in chat, and I'll parse them out of there. Or use the Q&A Zoom function. Or if you're watching on YouTube, just post in the YouTube chat. We'll be looking at all of that. And then at the end, I'll give Alexei the questions and Alexei can answer. And with that, let me introduce Alexei Mlavidov, the creator of ClickHouse. And Alexei, the floor is yours.
Yeah, thank you. Let me share my presentation. So today we will discuss what is new in ClickHouse release 22.6. It was released just today, or it wasn't. I'm not sure because my colleagues at this moment of time are preparing this release. So maybe it is already released, maybe it isn't, and it will be released a few hours later. What it is? Just a usual monthly release. But also it is ClickHouse summer release for June. We will have 3 of summer releases, and this is the first. It has 19 new features and 27 performance optimizations. So we have slightly more performance optimizations than features. By the way, what is your favorite? New features or performance optimizations? If you will have a choice, what you will prefer? Post your answers in chat and we will compare. I'm asking because I prefer bug fixes. So let me discuss the new features, then performance optimizations, and if we will have time, we will maybe dig into some bug fixes. About the new features, every release should have at least one flagship feature, and in the release 22.6, it is a grouping function. What is grouping function? Last month, I presented the new feature, grouping sets. It allows you to aggregate data by multiple groups in the same SQL query. And grouping function allows you to distinguish between these groups. What columns were used for aggregating? Maybe it is difficult to understand. Let me try to show you how it works. I will switch to my server, my favorite server, and make sure you will see something. And I will just copy paste some queries from one place to another, and you will watch and pretend, and you will be pretending that this is very, very entertaining to watch. So first, I will just show you what is with rollup. In this query, we have group by, we are reading from the statistics of house prices in the United Kingdom. Sale price of the houses, apartments, and so on. And I will do aggregation for analysis by year, by town, and by county. And I want to do some subtotal and total aggregation, and for this I will use with rollup. I already explained how it works in previous webinar, so I will not explain too much details, but basically it looks like this. It will aggregate by year, county, and town or city. In addition, it will also aggregate by year and county. It will do total aggregation by all cities and leave the value as empty. It will also aggregate by every year and leave county and town as empty. And it will also add one absolute totals, like totals aggregation into one total values. So you will have default values for year, county, and town. But what if some towns are actually empty strings? And you will have aggregation by this empty string in the result, and also another record for subtotal or total aggregation, also having this string as empty. And it will be difficult to distinguish. And with grouping function, it is fairly easy. You just use it in SQL. You provide your column as argument, and it will return 1 if this column was used for aggregation, and 0 if this column was omitted and we have total records by aggregating by other columns or absolute total. And it looks like this. So for total record, we have 0, year was not used, another 0, county was not used, and town 0. Here we have aggregation by year. Okay, pretty easy. But do you know what will happen if I will write multiple arguments for grouping like this? it will return some strange number. Here is 0, quite understandable, but here is 4, and here is 6, and then 7, and you have maximum 7. And if you did not read SQL standard, it can be quite difficult to guess what this value means. But we have implemented this function exactly as SQL standard said. So please post your guess, and if the first person who will guess correctly will win this amazing T-shirt. No, I will not take out this T-shirts from me. We have plenty of these T-shirts. Don't worry. By the way, Chris, do we already have some answers?
First one just came in. It's a bitmap order by group by parts.
And who is the person who is?
It's, I hope I'm pronouncing this somewhat correctly, Jahongir Sirajev.
Okay, I was quite a bit worried that the correct answer will be from my colleague who actually implemented this feature. Because when I tested this feature the first time, it was today. I was quite surprised by these values, and it was difficult to guess by. But Jahongir Sirajev, by the way, I'm also happy to see you in the list, has the correct answer. Yes, this is the bit mask of the columns that were used for aggregation. So 7 is 111, 6 is 0, no, 6 is 110, so 4 plus 2. And 4 is 100. Okay, and let me also finish my copy-paste exercise and show you this query. Here I do group by grouping sets. It is slightly more complicated than with rollup. It is actually a generalization. You can write arbitrary number of any combinations of columns, and you will get the result like doing group by one combination and doing group by another combination. Yes, and grouping function can be easily applied for this query as usual. Okay, this is about, I stopped sharing. No, I have to continue sharing. Here is about grouping function. What about another feature? New formats for exporting of data in JSON. We already have plenty of formats to output JSON, like JSON. Yes, this format is named just JSON. JSON compact, JSON each row, JSON compact each row. What else? I don't remember. So already 4 formats. And now we have 5, 6, and 7. Total 7 JSON formats. The new formats are named JSON columns, JSON compact columns, and JSON columns with metadata. I want to show you how does it work. It will be very easy to guess what these formats are doing and what they are for. And I will continue my copy-paste exercise. So I will query a table named Wikistat. Before I will do, let me show you what is this table. First, I will just estimate the number of records. And I have, oh, oops, it is difficult to read. 370 billion of records. Pretty big table. Maybe I will write like this. Format readable quantity. Yes, it is 370 billion. Also, just in case, I will check the size of this table and, okay, just the size of this table. I remember the column is named not bytes, but like data compressed bytes. Let me check. Probably it is named, yeah, total bytes. And here I will use format readable size function, and it is just 6.5 gigabytes. So we have just 2 bytes per record. Okay, and what can I do with this table? I can calculate some statistics. This is the table with Wikipedia page view statistics. I can take any Wikipedia page like ClickHouse or what else? What pages do Wikipedia have? Whatever you want. I can check any of our competitors, or if I just want to have some fun, I will write coronavirus, or Donald Trump or whatever. But today I will check the ClickHouse statistics. And it looks like this. If I use our new format, it will look like this. So basically it is JSON with columns, and columns are presented vertically, like ClickHouse likes to present data. Yes, it is column-oriented JSON format. And if I write JSON compact columns, it will look like this. Here is the object with keys as column names. Here is just an array. And JSON columns with metadata. It will look like this. You have your data, and you have plenty of some description about this data and statistics. I can remove limit, and it will look like this. So the question is, what this format? Why did we add this format? If you have JSON, you can easily transform your data from one format to another. Why do we need this column-oriented JSON in ClickHouse? Okay, I will answer this question. And to answer, let's write some JavaScript. Let me do some confession. Actually, I don't like JavaScript. I am not a JavaScript developer. But sometimes I have to write code in JavaScript. So please do some understanding. It will be just my demonstration of my mad skills. So what I did, I went to the internet and typed it in search system like JavaScript charting library and fast. Fast because I like fast libraries. I like to find everything that is fast, that is claimed to be fast on the internet, and just took it and use it. So I find this library named uplot from mysterious stranger Lenya. Yeah, it is a JavaScript library. In the README of this library, the authors stated that it is fast. So I want to use it. And the usage appears very easy. It is just 1, 2, 3, 4 lines of code in JavaScript. And this is not actually a code. So only 3 lines. In this line, I will query ClickHouse directly. ClickHouse has a REST API. I don't really need any driver for ClickHouse for JavaScript. I can just query it directly and it will return JSON, and I will parse this data also directly. So I will do HTTP post and just pass my query as a body. And my query is that I have shown you. Then I will wait for the result and initialize the library. And here is the result. So basically, arranging 3 lines of code, and I immediately get this nice looking chart. So this column-oriented format actually needed because I don't want to write JavaScript code. I don't want to convert my data. I want everything to work immediately, straight out of ClickHouse. When I just use ClickHouse and do almost nothing else, because I like ClickHouse. I don't like JavaScript, and I hope you share my observations. Yeah. By the way, do you know? Yeah. The good news: ClickHouse popularity is growing. But why do we have these gaps? Or not gaps, just and they look periodic. If you have the answer, please post in the chat. Why popularity of ClickHouse lowered in this time, and here? Christoph, do we have any hypothesis?
Nothing so far.
Quite strange. This should be easy to guess. Please. We have a second t-shirt.
All right, now we're getting the answers. So the first answer is from our friend Jack again. New Year and Christmas. Yeah, absolutely. So quite surprisingly, but people don't like to read Wikipedia on New Year holiday. Actually, I do. I read Wikipedia on New Year holiday, maybe even more than I supposed to do. But most of the people don't do that. Yeah, so Jack and Jill, maybe we will have to send you 2 pair, not 2 pair. I wanted to say 2 pair of pants, but we don't have ClickHouse pants. Okay, about the new features. Did you know that ClickHouse has support for OpenTelemetry? And you can use OpenTelemetry for ClickHouse introspection, for introspection of your queries. And more importantly, if you use ClickHouse just as one microservice in your infrastructure, you can do distributed tracing that will include ClickHouse just as one of the services. And you can
tie all the traces together. I cannot say that ClickHouse is a microservice. It looks like a mega service. So even if you have microservice architecture, ClickHouse probably will stand out, but stand out for good. So we already have support for OpenTelemetry for maybe already a year. And it is controlled by the setting something like OpenTelemetry probability. If you enable it, data will be collected into this table, this system table. You can export it into Jaeger, or Jaeger, how to pronounce this, or Zipkin. What is new in the release 22.6? We have added a lot more instrumentation. And after we did this, it appeared that you no longer can visualize this data inside Jaeger or Zipkin because it started to be too detailed. And you can get up to 1 million, maybe several million of spans from a single query. And I don't actually know, is it good or bad? Maybe we should add another setting and revert this feature. But it looks like this. And to visualize this data, we had to implement a separate tool. It looks like a kind of maybe dirty HTML page with JavaScript. Also, JavaScript written by C++ developer. So please forgive our ignorance. But now we have this tool. And on this picture, you can see 600,000 of spans. I don't remember what is what. Maybe orange is data reading, violet or magenta. No, it is violet, or something between violet and magenta. We have data processing. Blue ones, I don't even want to guess. If you look at some more simple query, it can look like this. So we read data, we aggregate it, then read again, aggregate. And somehow you may wonder why almost all threads are done aggregating, like there is some barrier or something like this. But basically, if you don't see empty gaps in between, it means you have 100% utilization of all the threads. And you can say that it is actually not so bad, at least looking at this picture. But why do I want to show you this picture? The only reason this picture looks nice. That's it. I don't have to have any other reason to show you nice pictures. Okay, let's continue. In the release 22.6, we have a contribution from external contributor adding a codec for floating point compression. It is named FPC, and I guess it means floating point compression. This codec is implemented by the description in paper. It is quite smart scientific paper named High Throughput Compression of Double Precision Floating Point Data by Cornell University. It should work good. So now we have implementation inside ClickHouse. And we can actually test it. Let me test it. Let me test it and see it if it will stand my testing like this. And to test it, I will use a table in on my server named system asynchronous metric log. First thing that I do with every table, I just run select count. I can run select count star, but if you write select count star, you don't show that you are actually ClickHouse expert. Only ClickHouse experts can write count without star. It is like not a secret ClickHouse magic. And every ClickHouse user should know. And I like select count without star. 4 billion records. And let me also show what is inside this table. Just 4 columns, date and time. I have time and date separately. And do you know why it makes sense to have one column with date time and another totally redundant column with date? And I want to ask this question for Christoph, because Christoph is an expert.
Yeah, that's a good question. I think I'll prove myself not to be so much of an expert as you think, because
let me don't hurry to give me an answer. You can think, but let me also show another query for you. My keyboard is quite loud, and my microphone is very near to keyboard. So I hope you can hear my keystrokes very clearly. And I will select subset of columns. Especially interesting are compressed bytes and uncompressed bytes. And also I will calculate the compression ratio. Some columns are compressed quite good. And date. Okay, Christoph, maybe you will explain.
Well, in the meantime, our good friend Robert has, I think, given me a hint. So I think it seems like date compresses a lot better than date time.
Yeah.
So is lower. I don't know.
This is absolutely the absolutely correct answer. And let's recall. We have 4 billion of records. And we have 4 billion of values of the date column. And it has compressed almost 1,000 times. It is like insane compression ratio. And to read 4 billion values, we only have to read 9 megabytes. And it will read fast regardless, even if you have one rusty HDD. Even if you have EBS GP2 with a size of 1 gigabyte, it will still read pretty quickly. And in some queries, you just only need date, and you don't need date time. And unless you query date time, it will be fast. reading date time will be just 10 times slower, but it's still 10 times, and it still has to read 90 megabytes. And I always care about performance. And also, system asynchronous metric log is a system table, and it will give people the best advice. The best advice how to organize a table for metrics, for dynamic metrics. And the answer is do like ClickHouse does. Put metric column in low cardinality of string, put date time and date separately, and also apply some codecs. And we have to figure out what codec will be better. Maybe FPC. Again, I will run describe table. We already have quite heavy compression codecs. I decided to apply ZSTD compression after delta encoding for date and date time. And I decided to compress value, the most heavy column, the most heavily, with Gorilla codec and ZSTD of size 3. Okay, so I hope we will have time. I want to do a quick benchmark of the codecs. Before I will do this, let me also demonstrate how you can use this table. What is this table for? It is for system-wide monitoring. So ClickHouse automatically monitors your system. If you install ClickHouse, even if you don't use it, it will collect data like a monitoring agent. You can attach Grafana, you can attach superset, whatever. And here is load average on my server. Okay, let me start doing some experiments. I will just copy paste these 10 queries. Kind of boring, but I hope you will like it. At least we are doing something smart. We are trying to reproduce a scientific paper, right? We can write a second scientific paper about reproducing the results of something. I like papers, I like science. No offense. And let me copy the data with insert select. I like fast queries, so I set max insert threads to 48. And I will do like this: insert, select. It is surprisingly fast. It is inserting data with a speed of 600 million rows per second. Actually, I am also very surprised because I did not see this this insert speed before. I only observed something like 10 million rows per second, maybe 50 million rows per second, but this is 500 million rows per second. No one database doing like this. If someone will say that my database are doing fast inserts, go to Twitter and post a tweet like BS. This is not true. ClickHouse is always faster. Don't even try. I just like to watch this speed. it looks like it is burning the fuel with incredible speed. Sometimes I run some hairy queries just for entertainment, to look at this progress, at this speed. It is a pure enjoyment. By the way, insertion speed is roughly the same for every codec. Maybe because I have so many CPU cores, it shows 50 or 48 CPU cores. And now finally, I will check how much data it is using. And I'm only interested with the value column. And I have tested different options with different codecs. Just ZSTD, just FPC, FPC and LZ4, FPC and ZSTD, and Gorilla and ZSTD. And let's look what is better. So compressed bytes, and this is the original table. This is what it is. Okay, I will just select the minimum, and we will check what it is. Asynchronous metric log 3, 500 megabytes. Just ZSTD. So ZSTD is the best codec. I don't have to apply Gorilla or FPC. Let's look what will happen if I apply FPC, so 6, and Gorilla 8 before ZSTD. 6 and 8. And actually compression is worse. So it does not make sense to apply FPC if you already have ZSTD. What if I just write FPC compression without anything? Table number 4, and it is, oops, much worse. And Gorilla is here. So FPC is actually worse than Gorilla and worse than ZSTD. And the results from scientific paper don't reproduce on this dataset. Maybe we should construct another dataset specifically for this paper to reproduce these claims. And I expect that it is fair, and if we do something like another sensor data, it will reproduce. But for this table, it does not make sense. So maybe it was too boring, but what are the takeaways? Always do experiments. Don't apply some codecs from random recommendations, from random blogs on the internet. Okay, done. Probably we should not have this feature, but it is nice. Nice implementation, clean, it works. Maybe it will be useful. What else? So, non-constant like and match. In the right-hand side of like, usually you can write only constant. But now I can do something strange. I can put like inside another like. And I will do like this. Extract from GitHub data the issues with title containing fast if repository like ClickHouse and slow if it is not like ClickHouse. So I will extract titles like ClickHouse is fast and Elasticsearch is slow. So You can put like inside another like, and I hope you will like it. Insertion into Zookeeper. So we already have system Zookeeper table in ClickHouse for introspection. You can use it to query Zookeeper. Now you can also modify Zookeeper. Please don't do this. This is like expert level feature. So Christoph, if you are an expert, you can use this feature. If you don't feel like an expert, ask someone else. So with this feature, you just insert subset of columns, name, path, and value, and it will create persistent nodes in transaction. And you can very easily mess up with Zookeeper. But sometimes, for some reason, you just want to mess up. And then you can use this feature. What about user-defined functions? Now, executable user-defined functions can have parameters. So you can create your own function with some external script. And it will have arguments, and the values will be streamed into standard input. The results will be read from standard output, and parameters can be used as a parameters command line arguments for your program. You just use this template expression and it will be substituted. And this template expression, you will just write it inside configuration file. Pretty nice. And what else for introspection? ClickHouse disks. This is a small tool inside ClickHouse package embedded into ClickHouse that can allow you to mess with ClickHouse virtual file systems. If you have ClickHouse on top of object storage, like S3, HDFS, Azure, or even HTTP server, we have this option. Then you can read and write files, list directories, remove files, hard link and copy, and whatever you want. Again, probably you don't need this feature. But if you want to do some ClickHouse surgery, no, ClickHouse does not require surgery. It is very solid and very healthy system. But just in case, we have this tool. Maybe we will be the only users of this tool. Maybe not. Now about performance improvements, and I have just 10 minutes to explain these improvements. And we have so many improvements, and I have only 10 minutes. How sad. First is about optimization for AArch64 CPU, like you have in your new shiny MacBook, like you can use in AWS. If you select AArch64 Graviton instances. And quite recently, we had most of our low-level optimizations only for x86-64. What are these low-level optimizations? It is very easy. If you look at the code, and everything is clean, fine, and nice, and suddenly you see something like underscore underscore something underscore underscore do magic. It is named intrinsic, compiler intrinsic. Compiler intrinsics are used to directly generate the code using SIMD instructions. And now we do this not only for x86, but also using ARM Neon extension. And almost every important optimizations are rewritten. Compression and decompression, UTF-8 processing, string functions, sorting, comparison, copying, many optimizations across the code. It is implemented by my friend Daniel Kutenin from Google, and also by Alexander Pipiluk, also my friend. And now I can say that AArch64 architecture is a first-class citizen for ClickHouse. How does it look? I will just show you some pictures. One query has speed up more than 1.5 times. Another just 23%. Another query almost 2 times. This is for writing into data formats. Text formats, we have UTF-8 processing validation, and now it is 2 times faster. Maybe it is 10 times faster, but now it is not a bottleneck of this query. So the query is 2 times faster. Again, almost 2 times faster on some insert queries. So nice pictures. I like to show you nice pictures. What else? Now we have proper stack traces for AArch64. In previous versions, if you get exception, you did not get stack trace. Sometimes you want stack trace. Stack traces in C++ are much better and nice looking than in Java. I don't like Java stack traces. And if you get used and tired of Java stack traces, look at stack traces from ClickHouse. They are better. Introspection tables are working, query profiler working. What else? Actually, we have a ton of optimizations. We have optimized coalesce function, multi-if, the distances in Hilbert spaces, number comparison, array matching, the distances on Earth and sphere. So the functions for geography. Everything is optimized by many people from our team. It looks like this. My colleagues are just crazy. They want to optimize something every day. And I am really happy with it. Yes, we try to optimize at least something every day. Like you wake up in the morning, you read the code, you get a new idea, you optimize the code. This is the principle. And we don't stop. We have even more optimizations. Order by with limit has been optimized. Order by single column, not necessarily with limit. Insertion into merge tree with multiple keys. Dictionary functions. Group by has been optimized in destructors. Not everyone trying to optimize cleanup stage of the query. We do. We have even lowered background CPU usage if you have thousands of tables. So optimization, performance optimization. Again, another optimization. What else? And we have 1, 2, 3, 4, 5, 6. No, 5. 5 more optimizations by external contributors. Because we are showing a good example for our external contributors. And contributors just, they can just look at us and repeat and try to do something that will surprise even ourselves. So, cold start for queries has been optimized by Anton Kozlov from Cloudflare. Virtual file system cache has been optimized by Han Shukai from Institute of Computer Science, Beijing. Join has been optimized, and we have plenty of optimizations for join still to do. Reading from S3 HDFS can be filtered by virtual columns. Surprisingly, we did not filter before, now we do. Again, by Amos Bird. Amos Bird is one of the most prominent contributors of ClickHouse. And some unnecessary copying has been optimized by engineers from Intel, because the engineers from Intel want to optimize ClickHouse for their newest CPU. So what about faster insert query? It is pretty easy to demonstrate. It was almost 11 seconds. Now it is just 7.5. More than 25% just has been cut off, has been shaved off. It is nice. Okay, what about something else? ClickHouse ecosystem with integrations, with external tools. What about ClickHouse Go driver? Now it is officially supported by ClickHouse team. And we have made 2 improvements. It has get JSON data type. JSON data type is quite new in ClickHouse. It is not even production ready. It is experimental feature. But my colleague Dale McDermott has implemented it in advance. So when JSON data type will be production ready, you will already get the support, production ready support inside Go driver. And it has support for structs, maps from Go. So please try to use it. And you will find it nice to use for semi-structured data. Another direction is to use the best implementation from Go Faster CH driver to improve ClickHouse Go driver. And we have communicated with the author of Go Faster driver, Mikhail Rozumov, if I remember correctly. And he suggested his help. So we will integrate low-level API that you can use to get even more performance. Now we have official integration with dbt. It has passed the test suite. It has better performance. Thanks to Guy Cohen from my team in ClickHouse. Now we have official integration with Airbyte. Yeah, by the way, dbt work has been, it is developed by Dmitry Sokolov, by external contributor, and now my team also participate and improve. Airbyte also supported thanks to Mark Zitnik from my team. Okay, what is next? I don't want to list every of maybe 100 of new features that we are going to have in this year. Just to highlight what we will have most likely in the next release in July. We are going to extend federated queries. We want to add Redis, MongoDB, Cassandra as table functions, and even to support querying external Zookeeper clusters. So you will be able to use ClickHouse to query Zookeeper that is managing your Hadoop. Sounds strange, but it should work and it should be useful. Okay, but if you want to read all 100 of features that we will have pretty soon, I invite you to discuss our roadmap. And that's it. Thank you for listening.
Great. I know we're a little bit over time, so let's maybe not ask all of the questions, but maybe just a few interesting ones if we can. Actually, on the last part, we had questions from Jack and from Ramazan Pollard on whether the new the new system Zookeeper table supports deletes, so that it's possible to clean up Zookeeper when required, or that it's actually possible to use ClickHouse Local as a Zookeeper client.
Yes, you can use the ClickHouse Local as Zookeeper client. You only have to put configuration file or just write ClickHouse Local -- config - file, pass to the file with Zookeeper configuration. And then if my expectations are correct, you will get system Zookeeper table. Yeah, we need to check this use case, and you will be able to select from Zookeeper, insert into Zookeeper, but not delete from Zookeeper. Ramazan, what do you want? This feature is already too dangerous. You want to make it even more dangerous. But I see you are the real ClickHouse expert. So maybe we should have this feature specifically for you.
Great. We had one question from Hena about the new JSON formats. Just in general, I think the JSON formats and other row-based formats are slow compared to native. And the question is if we have anything lined up for performance improvements for row-based formats.
I can say that most of performance is already inside ClickHouse, but not everything. There are a couple of ideas how we can improve even row-oriented formats. And one idea is to make a batch serialization, like vectorized serialization. You will take every column, apply a function like toString. So you will get a buffer with strings. And then you will just copy bytes around in particular order. So first type loop for serialization without virtual calls, and another for rearranging the bytes. But we suspect that it can be actually slower. But we did not conduct this experiment, so it is worth doing. If you will do, maybe it will have 10% chance or 20% chance to actually improve something. But still, we need to do more and more experiments. Christoph, do we have a t-shirt for Hina?
Yeah, I think so. Jack was saying that he already has some t-shirts. So, and anyway, we have so many.
Okay, Hina, you get this t-shirt.
Cool. We actually had a quite interesting exchange on YouTube that you can look at later. I'll send it to you. But it seems somebody has potentially improved how we store data in the asynchronous metric log table that you were showing. Apparently, they tested using LZ4 compression instead of the ZSTD compression on some of the delta encoded columns, and actually found that LZ4 is better. So it could be interesting.
Yeah, it should be better for speed, but it should not be better for compression, because ZSTD1 also includes LZ77. It is basically LZ77. That is the algorithm behind LZ4. And entropy coder on top of LZ77. So I'm quite surprised. Yeah, I will have to read.
Cool. And then maybe the last question from Gorav, when can we expect the S3 storage feature to be production ready?
S3 storage feature is production ready if you don't count zero copy replication. Zero copy replication isn't production ready. It is quite hacky. Actually, it works, but we continue to find some obstacles inside it. So I don't recommend zero copy replication. But what you can already do, you can replicate across regions. And if you have multiple regions, basically you should have and use local S3 storage inside every region. And you use normal replication. So data will be replicated between two S3 regions.
All right. And then let me just answer the last question myself here. There's a question in YouTube about that some function of ClickHouse are not recognized in Apache superset like group array. And we're actually working on having more official integrations and supported integrations with the Python ecosystem, specifically to also support superset. And so I'll send the comment to our colleague that's working on that. And hopefully at some point, all or most ClickHouse functionality will be supported in superset and in all other UIs, actually.
Christoph, do you know why exactly and in what place group array is not recognized? Maybe superset is generating queries with some other function like group concat from MySQL, and we only have to implement compatibility for this function.
It's probably something like that. I remember looking into superset, and there were, like, for example, ClickHouse data types that it didn't support, and maybe still some of them doesn't support. And it's basically just a matter of working on the ClickHouse dialect in superset to make sure that everything is mapped correctly and everything works. And it should be doable, probably.
Yeah, and I advise to do the following. Go to superset repository. It is open source, it is quite popular, even more popular than ClickHouse. Find the issue with this, or if you will not find, create it. And put as many likes as you can. Ask all your teammates to put likes and to write a comment. We badly need this feature.
Yes, please do that. All right. I think that's all of the questions that we have for today. So
okay. Thank you for listening. I'm so happy to see so many attendees.
Great.
See you next time.
See you next time. And maybe just one quick comment. If anybody of you or anybody who's going to watch the recording is in or around Paris, we're going to have a meetup in Paris on June 29th, I think. So in 2 weeks. So come hang out. We're going to have some talks about ClickHouse. And yeah, it would be great to see you there.
Yeah, I want to see you in person. We have so many topics to discuss. So please visit our upcoming meetup in Paris.
Okay. See you all.